A is the point 2 minus 5, B is the point 4 minus 9. Show that the gradient of the straight line passing through A and B is negative 2. So we're working with the gradient here. So the gradient is the change in y divided by the change in x. And remember, we have x and y coordinates. So let's work out the gradient, guys. So the change in y, so if we're going from A to B, y is going from minus 5 to minus 9. So we're looking for that change. So we are subtracting here, guys. And then x is going from 2 to 4, so 2 minus 4. Well, minus 5 minus minus 9 becomes minus 5 plus 9. And 2 minus 4 becomes minus 2. Okay? Minus 5 plus 9 becomes positive 4. We're still dividing by minus 2. 4 divided by minus 2 gives us a gradient of minus 2, which is what we're aiming for here. So that's 2 marks. The next part of this question, so C is the point minus 301, 601. Does C lie on the straight line passing through A and B? You must show your work in. Okay, so point to note here, guys. If C is on that straight line A and that's going through A and B, then it will have the same gradient. So from A to C will have the same gradient as what A to B does for it to lie on that line. So let's work with the coordinate A, which is 2 minus 5. And then we're going to work with the coordinate C, which is minus 301, 601. We're going to do the same process again. We're going to find the gradient. So we're going to do the change in y divided by the change in x. So the change in y, remember we have x, y coordinates. So the gradient is equal to minus 5 minus 601 for the change in y. And the change in x is 2 minus minus 301. So minus 5 minus 601 is minus 606. 2 minus minus 301 is 2 plus 301, which 303. Now if we simplify this equation, so we've got a negative divided by a positive, which gives us a negative solution. 606 divided by 303 is 2, because 303 is half of 606. So yes, C does lie on the straight line passing through A and B, because it has the same gradient.